Welcome to another ASC CPC training video. This video is part of our in-depth CPC tutorial series. In this tutorial, we'll cover CPC's Cascade feature. The Cascade function is located on the recipe screen. Starting at the main screen, let's move to the recipe screen by clicking the Recipe Screen button on the left side of the main screen. Cascade is a feature that allows CPC to control the air temperature of a specific level above the part temperatures in order to drive the part to the correct temperature. Each recipe can have this set differently in order to accommodate different load and part configurations. To help illustrate the Cascade feature within CPC and how it affects a cure cycle, I'll use a trend view screen from the reporting system of CPC. For additional information on the reporting system of CPC, see our CPC tutorial titled Reporting System. As you can see, this typical ramp is showing time on the bottom and temperature on the right. In the upper left, we see the legend for sensors we're viewing. Back at the recipe screen, you can see that the recipe is calling for 360 degrees at a rate of 5 degrees per minute. We are controlling off high TC. Going back to our example trend screen, this is the T-set part, or part temperature set point. This will follow the recipe rates of 5 degrees per minute to 360 degrees. We can see that the low TC here is lagging behind the part set point for the cure. The distance between the low TC and the part set point is called error. Cascade works on a ratio. For example, if you had Cascade in set at 1, and Cascade out set at 2, you'd have a 1:2 ratio. This means that for every 1 degree of error between the low TC and the part set point here, CPC will drive the air temperature of the equipment up by 2 degrees for a new temperature set point. This is why we see the air temp in this example at a higher set point than the part temperature. Since Cascade allows you to make up the error, it also shortens up the cure cycle time. As you can see here, it draws the low TC into soak sooner than if it was not being pulled up. Had we not used Cascade, the air TC here would be close to the part rate, meaning it would take longer to get into soak. This is also the case on the cooling side. Cascade will also shorten the cooling by driving the set point lower to reduce the error and decrease cycle time. The Cascade out also functions as a limiter. This limit is the maximum temperature that Cascade can drive the air temperature above the part set point. If you were to use a Cascade in of 50 and a Cascade out of 100, this would allow 100 degrees output for every 50 degrees below the set point. If the error were to increase to 60 degrees, the output would not increase by the 2:1 ratio to 120 degrees. Instead, it is clipped at 100 degrees based on the Cascade output setting. Since performance of a cure cycle is dependent upon the individual capabilities of your equipment or system, there are no pre-configured settings for the Cascade feature. This feature should be fully tested with a sample production part to understand how the Cascade feature can improve your cure cycle performance prior to running production parts. This concludes CPC's Cascade feature tutorial. Thank you for watching.